Hello everybody, my name is Anya Kantraj. So today I'm here with another video of the subject operating systems. So let us look into the contents. So today we're going to discuss about the type of scheduling algorithms, the disadvantages of scheduling algorithms and the advantages of scheduling algorithms. So the types of scheduling algorithms. So what is a scheduler basically? A process scheduler, it schedules different processes to be assigned to the CPU based on a particular scheduling algorithm. So there are basically 6 popular process scheduling algorithms. So the first one is the first come, first served. It's also called as FCFS scheduling. The second is short job next scheduling. It is also known as SJN. The third is the priority scheduling. The fourth is the shortest remaining time. And the fifth is the round robin scheduling. Sixth is the multiple level scheduling queues. Next. So these algorithms, they can be either non-primitive or primitive. We'll look into that in the further slides. So non-primitive algorithms are designed so that once a process enters the running state, it cannot be preempted until it completes its allotted time. Whereas the primitive scheduling is based on priority, where a scheduler may preempt a low priority running process anytime when a high priority process enters into a ready state. So let us look at the first one, which is the first come, first serve scheduling algorithm. So in this scheduling algorithm, the jobs are executed on first come, first serve basis, and it's a non-primitive and pre-primitive scheduling algorithm. It's easy to understand and implement, and its implementation is based on first come, first service queue. So poor in performance as average wait time is high, which is a disadvantage of the first come, first serve scheduling algorithm. So let's look into the example above. So here in the example mentioned, we have the processes from 0 to 3, and the arrival time is given, execution time is given, and the waiting time is given. So the waiting time for each processes is calculated as the service time minus the arrival time. So for the P0, it is 0. For P1, it is 4. For P2, it is 6. And for P3, it is 30. So the average waiting time is nothing but the sum of all the waiting time of the given processes, which is, as mentioned, it's 0 plus 4 plus 6 plus 13 divided by the number of processes. It's P0, P1, P2, and P3, which are nothing but 4 processes, and hence the division gives you an answer of 5.75. So let's look into the second algorithm, which is nothing but the shortest job next algorithm. So this is also known as the shortest job first, or SJF. It's a non-primitive preemptive scheduling algorithm. So best approach to minimize the waiting time. So that's the advantage of the shortest job next. And it's easy to implement in batch systems where required CPU time is known in advance. And it's impossible to implement in interactive systems where required CPU time is not known, which is the disadvantage of shortest job next. And the processor should know in advance how much time the process will take place. So these are the two advantages of the shortest job next. So let us look into the example above mentioned. So it's a given table of processes and their arrival times. So looking into the example, we can schedule the exact shortest job next of the given example. So let us look into priority scheduling. Before that, let's move into the example mentioned here. So first it says that the given processes, the arrival time is mentioned, the execution time, and the service time. It's nothing but we have to calculate the waiting time of each processes. So the waiting time, before scheduling the waiting time, we are supposed to draw the required graph. So here is the timeline, which includes the processes from 0 to 3, which has the least arrival time, then 3 to 8, and then 8 to 16, and 16 to 22. Later, calculating the waiting time, it is nothing but P0 is 0, P1 is 4, that is 5 minus 1, and P2 is 14 minus 2, which is nothing but 12, and P3 is 8 minus 3, which is nothing but 5 seconds. So henceforth, the average waiting time is nothing but the calculation of the entire number of waiting time processes divided by the number of processes mentioned above. Henceforth, there are 4 processes, and adding we get as 21 divided by 4, which is nothing but 5.25. So third one, let's look into the priority scheduling. So it's a non-primitive algorithm and one of the most common scheduling algorithms in the batch system. So each process is assigned a priority. So the process with highest priority is to be executed first and so on. That is the procedure in the priority scheduling. The processes with the same priority are executed on the first come, first some, first served basis in case the priority of the processes are same in terms of the time mentioned in the given table. So next is the priority can be decided based on the memory requirements and the time requirements or any other resource requirement. So here it is mentioned regarding the memory requirements of the priority scheduling. So it is nothing but it depends on the time also, resources also, and the memory. So the priority can be decided. So here let's look into the given process of the priority scheduling and let's see how to solve the above problem. So the number of processes are nothing but 4, 0, P0, P1, P2, and P3. And the arrival time is mentioned as follows, and the execution time is mentioned as follows, or also known as the burst time, and the priority is mentioned as follows, and the service time is given. So once constructing the timeline, we get the above processes waiting time as P0 is 0, P1 is 10, P2 is 12, and P3 is 2. So next, calculating the average time, it's nothing but the sum of the processes mentioned above with the respective waiting time divided by the number of processes, which is nothing but 4. You're going to get it as 24 divided by 4, which is nothing but 6. Next, shortest time. So the shortest remaining time, which is also in abbreviations mentioned as SRT, is a primitive version of the SJN algorithm. So the processor is allocated to job closest to the completion, but it can be printed by a newer, readier job with a shorter time to completion. So impossible to implement in interactive systems where required CPU time is not known. That's the disadvantage of the shortest remaining time algorithm. And it's often used in batch environments where shortest job needs to give preferences. It is the advantage of the shortest remaining time scheduling algorithm. So let's look into the round robin scheduling algorithm. It's one of the type of the scheduling algorithm. So here, round robin is the primitive process scheduling algorithm. Each process is provided a fixed time to execute. It is called a quantum. Once a process is executed for a given time period, it is preempted and the other processes executes for a given time period. So the context switching is used to save states of preempted processes. So let us look into the example of round robin where the given time is in quantum, it's nothing but 3 seconds. And the given timeline is as mentioned here, 0 to 3, 3 to 6, 6 to 9, 9 to 12, 12 to 14, 14 to 17, 17 to 20, and 20 to 22. So waiting time for the each process is nothing but the service time minus the arrival time, or also the burst time minus the arrival time, which is nothing but 0 minus 0 plus 12 minus 3, which is 9 for the process P0, and for the process P1, it is 3 minus 1, which is nothing but 2 seconds, and for P2, it is nothing but 6 minus 2 plus 14 minus 9 plus 20 minus 17, which is nothing but 12, and for P3, it is 9 minus 3 plus 17 minus 12, which is nothing but 11. So the average waiting time is as follows: 9 plus 2 plus 12 plus 11 divided by 4, it's nothing but 8.5. So next, let's move on to multi-level queues. So what are basically multi-level queues? The multi-level queues are not an independent scheduling algorithm. They make use of other existing algorithms to group and schedule jobs with the common characteristics. Multiple queues are maintained for processes with common characteristics. So each queue can have its own scheduling algorithm. Priorities are assigned to each queue. For example, a CPU-bound jobs can be scheduled in one queue and all the input-output bound jobs in another queue. The process scheduler then alternately selects the jobs from each of the queue and assigns them to the CPU based on the algorithm assigned to the queue. So that is the priority which is assigned to each queue expressed in multi-level scheduling algorithm. So it's basically another one is maintained for the processes with common characteristics. That's the main advantage of using a multi-level queue. So what are the advantages and disadvantages of scheduling algorithms? So let's come into the first come first serve algorithm. Advantages is nothing but it's simple and easy to understand. And FCFS provides fairness by treating all the processes equally and giving them an equal opportunity to run. And the FCFS guarantees that every process will eventually get a chance to execute as long as the system has enough resources to handle all the processes. And FCFS has low scheduling overhead since it does not involve frequent context switches or complex scheduling decisions. FCFS is well suited for long running processes or workloads that do not have strict time constraints. So disadvantages of FCFS is that the process with less execution time suffers, that is the waiting time is often quite long, and it favors the CPU bound processes than the input output bound processes. And here the first process will get the CPU first, other process can get the CPU only after the current process has been finished its execution time. Now basically, suppose the first process has a large burst time and the other process have less burst time, then the process will have to wait more unnecessarily, which will result in more average waiting time. That is nothing but the convoy effect, it's also called as. And this effect results in lower CPU and device utilization. So the FCFS algorithm is particularly troublesome for multi-programming systems, where it is important that each user get to share of the CPU at regular intervals of time. So next is the shortest job first, which is primitive and non-primitive. Advantages is that the shortest jobs are favored and it's probably optimal. That is, it gives the minimum average waiting time for the given set of processes. And the disadvantages is that it may cause starvation if process keeps coming. The problem is solved by aging. The disadvantages is that SJF may cause starvation if shorter processes keep coming. This problem is solved by aging. It cannot be implemented that at level of short-term CPU scattering. Next is the round-robin scheduling algorithm. Advantages is that every process gets an equal share of the CPU and the round-robin is cyclic in nature, so there is no starvation. Disadvantages is that the setting of the quantum is too short, which increases the overhead and lowers the CPU efficiency, but setting is too long, which may cause a poor response to the short processes. The average waiting time under the round-robin policy is often long, and if the time quantum is very high, then the round-robin degrades to FCFS as first come first serve scheduled algorithm. So the fourth one is the priority based, which is nothing but the advantages are as follows. It provides a good mechanism where the relative importance of each processes may be precisely defined, and it allows for the assignment of different priorities to be processed based on the importance, urgency, or other criteria. Disadvantages is that if a high priority process uses up a lot of CPU time, low priority process may starve and to be postponed indefinitely. The situation where a process never gets scheduled to run is also called a starvation. Second point is that another problem is deciding which process gets which priority level assigned to it. That's the another disadvantage of this priority level scheduling. And looking into the multi-level scheduling, advantages is that application of separate scheduling for various kinds of processes possible, which include system process, interactive process, batch process, and student process. Disadvantages is that the lowest level process faces the starvation problem. Sixth is a multi-level feedback queuing queue algorithm that's also known as MFQS. in abbreviation. Advantages is that it's a low scheduling overhead, it allows aging, thus no starvation. And disadvantages is that it's not flexible. So it also requires some means of selecting values for all the parameters to define the best scheduler. Thus, this is also the most complex. So thank you for watching my video. Please do like, share, subscribe, and stay tuned for more updates in the upcoming video. Thank you.